5 in image processing techniques or image compression. See, first we know fundamentals of image compression. Here the term data compression refers to the process of reducing the amount of data required to represent a given quantity of information. See, the compression, it is the process of reducing the amount of data to required to represent a digital image. So the reduction process is done by removing the redundant data. So after storage or transmission of the compressed image, decompression can be performed to reconstruct the original image. So for example, if we want to store a 1200 cross 1600 color image, then the space required to store the image is 1200 cross 1600 color image. So the color image is represented 3 primary colors. So is multiplied by 3. Int each pixel is represented by 8 bits. So multiplied by 8. So the total storage space required for storing 1200 cross 1600 color image is 5.76 MB megabyte. Then, so this is the basic block of image compression model. So here the image compression system is composed of two distinct structural blocks. One is encoder and another one is decoder. So encoder performs the compression process and decoder performs the decompression process. So here first encoder consists of source encoder and channel encoder. So the original image is encoded, after that it is transmitted through the channel. That receiver side decoder is there. So here channel decoder and source decoder. So what are the encoding process performed in source encoder and channel encoder? The same reverse process can able perform in decoder side, channel decoder and source decoder. So from this f of x comma y is the decoded image which is equal to the original image f of x comma y. So here what are the major blocks in source encoder means one is mapper and quantizer and simple encoder. Uh, Mapper, quantizer and simple encoder. So these three blocks are in source encoder. So after encoding that, channel encoder are used to encode the channel. After that the signal are transmitted. In that source decoder side, symbol decoder and the inverse mapper is there. So this is a reverse process of source encoding. So finally we can get f cap of x comma y. And types of image compressions, one is lossless error free compression and another one is lossy compression. So here lossless error free compression, it is a reversible with no loss of information, and the image after compression and decompression is identical to the original image because here lossless, no loss. So therefore decompressed, after decompression the decompressed image is same as the original image. So it recovers the exact original image data. So compression ratio is small. So the applications of lossless compression techniques we are using in medical or business document side and satellite imaging and digital radiography. Uh, so these are all the major applications of lossless compression techniques. And lossless error-free compression methods. So what kind of techniques we are using lossless error-free compression method? Variable length coding. So under this we have two different codings. One is Kaufman coding and arithmetic coding, and bitplan coding and lossless predictive coding. So these are all the techniques yeah, for lossless compression methods. So variable length coding. So it is a simplest approach for error-free compression. It reduces only the coding redundancy and it assigns the shortest possible code word to the most portable value. So here two types, one is Kaufman code and another one arithmetic code. Arithmetic code. Here there is no one-to-one correspondence between source symbols and the code words. The simple arithmetic code word assigned for a sequence of source symbols, and a code word is defined in the interval of numbers between 0 and 1. Then lossless predictive coding. So here encoder side we are using predictor and nearest integer, and so the comparator or E of n is measured from the comparison between f of n and f cap of minus n. I mean E of n is equal to f of n minus f cap of n. So after that value. The resultant value of E of n is encoded by using symbol encoder. That is the final resultant value is called as compressed sequence. Then in the decoder side, the compressed sequence is given as input to the symbol decoder. Okay, so here after again decompressing, we can get the decompressed sequence. So this is lossless predictive coding block. And lossy compression methods, it is irreversible lossy with loss of some information, okay, but acceptable level. So here three different lossy compression methods are the transform coding, wavelet coding, and lossy predictive coding. So this is the encoder block of lossy predictive coding. So here input sequence f of n is given and e of n error is measured. Before that, the signal is given to this quantizer, and the quantizer result is represented as e dot of n. This is given to this summer. So here e dot of n and f cap of n. So here we are using one encoder block predictor. Okay. So after that, the e dot of n is given to the symbol encoder. So after encoding, the resultant value is the compressed sequence. The decoder side, compressed sequence is given as an input to the symbol decoder. Again, we are using reversible block of the encoding techniques. There is a decoder. So finally, we can get decompressed sequence. Then, image compression standards for still image and videos are first. Standards for still image has two types. I mean, one is binary image compression and the continuous tone still image compression. So here for binary image compression, the compression standards are CCITT group 3 and group 4 and JPIG 2, 1 and 2. For continuous tone still image compression techniques are JPEG, JPEG LS, JPEG 2000. For video, the image compression standards are DV, H.261, 262, 263, 264 and MPEG 1, 2 and 4.